Good evening. My name, if you don't know, is Brian Boigon, and I'm the director of the Bachelor of Arts of Architectural Studies program at the Daniels faculty. And it's my pleasure to welcome you here tonight to introduce you to our featured speaker, Greg Lynn. As you know, this lecture is part of our popular Bulthaup lecture series, part of the Daniels faculty schedule of public programs. The Bulthaup lectures showcase an international array of some of the best and brightest in the field of architecture and design, and Greg Lynn is no exception. So far this year, thanks to Bulthaup sponsorship, we've had 3 outstanding talks featuring Nadir Tarani of the award-winning Boston-based firm NADA, Hanif Kara of ACT or AKT in London, and our very own Mason White, along with Lola Shepard, whose firm Lateral Office is curating the Canadian exhibition in this year's Venice Biennale of Architecture. Next week, on Thursday, April 3rd, we will present our last Bulthaup lecture of the year, which will feature 2 speakers, Adrienne Guz and Jill Thierry of the firm West 8, whose award-winning projects include Toronto's Central Waterfront. Bulthaup is renowned worldwide for its architecture of living spaces and is established here in Toronto at 280 King Street West. The design professionals who spec their living spaces to their clientele recognize the brand for its architecture, innovation, and in this case tonight, material precision. I'd like to take a moment to acknowledge Stefan Sivlo. Are you here? Hi. Thank you for attending and joining us this evening and for your continued support. King Street East. Sorry about that. Okay, so now on to this evening's featured speaker. So before I introduce Greg Lynn, I wish to set the stage for his entry into a variety of pathways on which Greg Lynn has had an impact and continues to carve out his designs as they do. I recently had the opportunity to attend one of Greg Lynn's studio juries last year at UCLA. It was here that I was exposed most recently to his fantastic obsession with movement, robotics architecture, self-propelled form-making, vector-based random field theory, to name just a few of the characteristics of this architect's world and teachings. My exposure to the Greg Lynn effect, is one of great interest to me, as I had been and continue to believe that his terrain, made up of a host of moving parts and design deliriums associated with generating forms out of movement systems, will be where the future takes us. Not just him and alone, but where we will all be heading when we design today for tomorrow. Why then? Clearly stated, of course then. But why now? Because central to the new practice of architecture and computing is now the presentation of code-based surface located on an algorithmic grid that now produces self-organizing design methodologies and its attendant practices like Greg Lynn's. It is here now at the outer edge of the plastic art of architecture where code warriors of a new generation made up of complexity theorists and video game architects will take the run of the store and look into the catalological world of Greg Lynn's influence to help map out and establish a new space for generating form which is not shaped by Rhino or Minecraft, but automated by lines of code and their attendant potential robotics, towards a new kind of architecture method, the computer, its algorithmic cartography, and the casting of new machines for living. Enter Greg Lynn. He was one of the first architects, or shall I say he was one of the first beginners in the area of computational automation. I recall, as a matter of fact, in the early 90s, attending a review at Columbia where he was just beginning to tinker with the potential of the digital. His students' work and attendant juries were crude, as I was, and yet awesome, not me. There was no Rhino, there was no SketchUp, let alone the likes of Grasshopper, Crytek, and Unity physics engines. Adobe Photoshop was probably in its first release. Browsers were still in their infancy and could barely host a video, let alone stream anything or make something out of something else. There was no social media, save the thing called voicemail, which Tom Levine out of Princeton was most likely the only historian on the planet who could pontificate on its analogical origins. And there was no such thing as Pirates Bay. So no copy of a copy of a copy, no real digital bit farming. In any case, Greg Lynn was there, toying with the world of digital architecture, and he has continued to lock and step in this world ever since. He has innovated by his own hands and made things that stand up, or barely stand up, on a screen for more than an animated instant. Greg continues his foray into the magical world of poetic imagination embedded in the digital and its fabrication up to and including things. By way of chance, later last year, I visited his exhibition on the archaeology of the digital at the CCA. However controversial this exhibition is, by whom and by what it does and does not include, it clearly staked out a space in which early computational design sequencing begins to emerge. Like all stakes in the ground, whether they be by Shakespeare or Koolhaas, curating is always rife with the critical and the yell and the holler from the audience. Make no mistake, Greg Lynn's exhibition is not without its flaws. Yet I would say all new things are flawed by the paradox of making anything new out of something already here or there. Regardless of that, Greg Lynn, architect in motion, studio twister, sailor, tinker, tailor, soldier, spy. In addition to Lynn being an innovator in redefining the medium of design with digital technology, he is a pioneer in the fabrication and manufacture of complex functional ergonomic forms using computer numerically controlled machinery, also known as CNC. Greg was named one of the most innovative people of the 21st century by Time magazine in 2001. I would have voted for him. And in 2005, Forbes named him one of the 10 most influential living architects. In 2008, he won the Golden Lion at the 11th International Venice Biennale of Architecture. And in addition to receiving professional awards from AIA and Progressive Architecture, his Korean Presbyterian Church of New York was officially listed by the New York City Landmarks Commission as one of the 30 most important buildings built in the city in the last 30 years. I'm going to digress once and for all before introducing Greg. History is in the making. As some of you might argue, history has its way with us. As for me, when I see the digital historically unfolding in all its folded glory, it is perhaps by chance alone when a design worker like Greg Lynn steps in and tries to push the boundaries of a machine, tweaks the calibration of an automated system, bends a material just a little too far so it snaps like a memory metal back to its state space. That's history and its technology for you. A mashup of playing with the world and making it to succumb to a logic yet known by it. That is what Greg Lynn is priceless at. Making history pay the price of entry for a future that will be built by bits and molecular entanglement and not a moment too soon. Now, a final word about sailing. A Voyage to the North Sea by Marcel Bruthers, 1974. One of Belgium's most important conceptual artists made a 16mm silent film named A Voyage on the North Sea. The film took it upon itself to reorganize a trite piece of middle-class art jewelry, a bad painting of a sailing schooner at sea, and jettisoned it into a series of small filmic photographic details which turned the not masterpiece into an existential choreography of brilliant torrents and fragments. It was a rigorous and poetic redisplay of movement and aesthetics. I bring this reference here this evening because I cannot always, and I do not always, think of Bruthers' Voyage on the North Sea when I try to imagine how Greg Lynn's episodic design life turns its attention to a sailboat. since it seems at first sight to be a subject of typologies and topologies which have advanced the science of shipping incrementally, slowly, towards an efficiency of less resistance and more equilibrium. So the analogy of Bouthaire is taking apart a ship photograph, filmic graph, film by film, akin to Lynn's reverse assembling of a new material science of design to the hull of a sailboat echoing the digital domain of the sea level, is a step towards what I see he is about to attempt. Ahoy there, Greg Lynn. Greg continues to practice and live in LA, teach and research at UCLA, where he obsesses about his monographic inventive world of sailing, robotics, geometric concerns, hulls, hardware, carbon, and voyages in design. His lecture titled Carbon Dating, Greg will discuss recent architectural flirtations with lightweight moving, sometimes robotic rooms and projectiles using composite construction. It gives me great pleasure to welcome my good friend and colleague, Greg Lynn.
Okay, that's the worst. How do I follow that up? This lecture is going to pale in comparison to the introduction. So, no, thanks for having me. And our original deal was that I was going to give a 20-minute talk and have a 40-minute conversation with Brian. And we've negotiated it down to a 40-minute talk and 20 minutes of conversation, but I'm holding to that because I think it's more interesting than a lecture. And I also don't see Brian enough, and we were together at a time when he was doing the cartoon regulators and culture lab, and I was doing animate form. And however long ago that was, I hate to say it was 2 decades ago, but 2 decades ago, motion was really what preoccupied a lot of architects. It was on our desktops, it was in the infrastructure that people were looking at, it was everything. And mostly in reaction to journalists who made an immediate jump to say, if you're using animation software, your buildings must move. That I had a strong reaction and said, no, I want to think about motion in a more theoretical way and really kind of back myself into a Baroque model of space in the kind of thought of Wolflin, that I was interested in capturing dynamism in a fixed, non-moving built environment. And what that led to in thinking about motion in phenomenal terms, and here I'd borrow the phenomenal literal equation for transparency and just apply it to motion and see how it works. But in thinking about phenomenal motion, it really led to, tectonic maximalism. Like, if you used to build it in 10,000 pieces, how can you build it in 100,000 pieces? If you used to have 20 typical details, how can you have 200,000 unique details? How could geometric complexity be achieved? And how many ways could you mechanically attach parts together? And this legacy, I now feel not haunted by, but burdened with. So like the Korean Presbyterian Church, every single steel connection in the primary steel of the building was unique, and most of the secondary steel connections were unique, and we had to draft all those, and every surface of the interior was unique. And the idea is, and the reality is, that the space has a dynamism as you go from surface to surface or component to component. But the idea of motion was a purely phenomenal one, trying to capture rhythm and capture pattern in tectonics. So I'm trying to see what other opportunities there are, and in the last 4 or 5 years, I've actually returned to motion and started to think about things that move and to think about robotics and digital automation not in how can we use these things to build buildings, but how can we build that kind of dynamism and intelligence into the built environment, and how would that change architecture? And how would that change the architecture that doesn't move? But so to kind of track, because I think it's important to go through a little bit of some of these episodes, the translation of curves and vectors into sequenced facets and rhythm, led me into plastics, which I think has nothing to do, other than that they're very lightweight and efficient, has nothing particularly to do with motion. But one of the things that I found is that, here in these index pavilions, I was asked they're for 2012, but I was asked 3 years ago to design these pavilions for a traveling award. Let me see. I guarantee this is the only problematic file. Otherwise, this will go smoothly. So I actually want to show this, Pam. Is there a way I can exit out of this and just launch the... Oh, there we go. Okay, so I was asked to do these pavilions for the preeminent sustainability awards in the world that are put on by Index, which is sponsored by the royal family in Denmark. And it's called Index Designed to Improve Life. And they have 5 divisions of award that go from infrastructure to medical technology to architecture, urbanism. And they select 80 finalists, and they tour those 80 finalists along with the 5 winners all over the world to design festivals. And when we started the project, they said, well, it has to be a sustainable material. So we think it should probably be wood. And also because they're in Scandinavia, they immediately went towards wood. So when I asked them what their concerns were, the previous pavilions had taken 12 shipping containers to move to each venue, and they go to 6 or 8 different places a year, and they would get very vandalized while they were at all these places. So they said, well, vandalism is a problem, so they have to build 2 of everything, and shipping is a problem because they have to send 12 containers around at about $4,000 one way per trip on average. So, and they gave me a budget. And I said, well, can I include the shipping and the vandalism in my budget? And they said, yeah, sure, actually. We could look at the whole logistics of the thing as one thing. So I then said, well, if we make it out of carbon fiber reinforced plastic that the car industry uses for vacuumforming or thermoforming, I could make it totally indestructible. And I could make it so it's so light that 2 people could put each pavilion together. So if there's 9 pavilions, a few people could do all the work. And I can fit all 9 pavilions in 1 shipping container instead of 12. So we did this for 1/6 the budget in terms of logistics. So I got to spend twice as much on the carbon fiber pavilions and still be less than 50% of what they told me the budget was. So that's when I realized that plastics and composites, if you think of them in terms of logistics, oops, sorry. If you think of them in terms of logistics, become the most sustainable things you can use. So the carbon, which is sand, which is cooked, usually with nuclear energy in Japan, sounds really bad, ends up being a better material for sure than a brick, which you fire and have to truck around with all that weight, but even better than wood that you got to fill with chemicals to keep it from rotting and keep the bugs off. So plastics became my green material. And I've been spending a lot of time looking at plastics in all kinds of forms and all kinds of ways and thinking about how they move around and how they assemble. Because of people like Didier and Monica and Matthias Kohler, I thought a few years ago that I better have a position on bricks, just because it seemed like all my colleagues were thinking a lot about bricks. And I never really had given a brick a thought. And so I thought I'd try to invent a brick. And my kids were young back then. And my wife, who grew up in Italy, is very attached to bright plastic objects. And we had a garage filling up with rocking horses and water things and sleds and all these cute plastic toys. These are Germans have ducks. We had some US shark sleds. We had eggplants from Italy, but we had all these plastic toys that we were saving. And I thought, why not just cut these plastic toys up and use them as bricks, and I'll make a wall in our house of all of my kids' toys. And that ended up leading, for the Biennale, to going on eBay and getting as many copies of these toys as I could get. This is a table made out of ducks. And we got a couple hundred of these ducks over a year. You know, high definition laser scanned them, composed them digitally, put them on a turntable, cut them with a robot, and then a very laborious process of assembly goes on where they all get welded together. And we couldn't get enough toys to do these things, so eventually we designed a custom brick, which is the blob wall brick, and with Panelite started marketing these custom walls for interiors, mostly for kind of hospitality interiors and things like that. And then eventually even combined the bricks and the toys into a series of fountains that I've done. But these things, you know, they're incredibly light. Like that fountain floats. Like we had to add weight to it to keep it from floating on the pool that it sits in. So it's, you know, it's got the character of rustic stone, but the lightness of paper. And that focus on plastics started to lead to, instead of maximization of components and complexity, like these are incredibly complex to fit together. I mean, you can imagine the interlock and the die lock between pieces, it's a nightmare. And the assembly is incredibly intricate and not robotic. And it really all started with a meeting with Rolf Feldbaum, the owner of Vitra, where I was at. He asked me to do a chair. He said, I think, you know, the chair is much harder than a building, and a chair is a statement for an architect, and I'm going to give you a chance to do a chair and be in my stable of designers like the Eameses and, you know, Panton. And I was really, really nervous. And he suggested that I bring 2 or 3 proposals. And so I brought proposals that gradated in complexity, from a chair which was made out of over 10,000 pieces to a chair that was made out of 2 pieces. And I would never even think to bring the 10,000 piece one, but I presented it to him, and I said, well, you know, typical chair is made out of 12 parts, but with digital technology and CNC manufacturing, I can make a chair out of 10,000 unique parts. And he kind of looked at me. I realized that's like the most retarded thing he's probably ever heard. You know, that's like absolutely, you know, I mean, literally retardataire, you know, because innovation is, you know, if you talk to somebody in the automobile industry, their drive and innovation is to part reduction and integration. So instead of having 5 pieces that need to get jigged and fitted together, they would like all 5 of those pieces to be cast and manufactured and placed into one part. That's where they see innovation. They see reduction of components, integration and multi-use of one part to do 2 things. That's what they see as innovation. Only in architecture would a whole field say, we have digital technology and we can now make things more complicated. And that's innovation. It really, it's worth thinking about why we're the only field that would do that, but I'm pretty sure we're the only field in history that's ever made that a kind of mandate for a whole discipline, and it's insane. So I've been trying to reduce parts. I've been trying to integrate components. I've been trying to use surfaces and shells to do the work of structure. So instead of having primary structure and secondary structure and cladding structure, I've been trying to collapse those things into single systems. And to do that, I've been looking at a lot of plastics. With the Pretty Good Life showroom, it was a ridiculously heavy interior, but it was all monolithic in the sense that the pegs and the shelving and the wall surface was all one set of stacked components. With Uniserve, with this interior conference room, we were trying to get everything into self-supporting plastic panels. And really it was with the Alessi Coffee and Tea Towers where Alberto Alessi said, look, architects never put handles on their designs because they don't know how to integrate the handles in, so make sure you put a handle on. And so I decided to make these sets that were all handle. So there's an interior flask and then a superformed titanium shell that's siliconed onto it so you can grab it anywhere, and it's kind of invites you to grab it with your hand. I mean, it wasn't really designed from a hand, but it was designed to be grippable and to invite being grippable. But you know, what would have been done with a dozen or so different elements and processes was done in a oven with 0 atmosphere and 2 graphite tools where we just exploded the coffee set in one shot. It was done. So each one of those containers is just 4 parts with 2 processes. Same thing with the kind of commercialized cups. It's one slip molded bone china object that the handles and the volume are all in one shot. So it's a one piece instead of a Turkish coffee cup that would have a metal, forget the name of it. It's the name of those paper things Starbucks uses. But instead of having the thermal barrier in the cup in 2 materials, it does it all with one material with the airspace in it. And then, like I was saying, with the Vitra chair, the idea was to have a hard and a soft surface and to do the legs, the arms, and the back with one hard composite shell, and then to do the top with a 3D knitted cloth. And it's the same as the fly knit shoes. The furniture industry has been using this stuff for about 10 years, where they digitally knit, say, more than double the number of knots, where it has to go over the seat and the arms versus where it goes along the front. So they digitally add knots like crochet to give it a 3-dimensional, like preformed surface. So it's, it's like a brassiere or something in the sense that it's shaped, and it is cast into foam to then give it the structure. And there's more than 2 pieces here, but the base then, which is the 4 legs and the arms and the back, is what it gets bonded to give it its comfort. And a lot of people that have never been seated in it think it looks uncomfortable, but it's, for me, the ergonomics was really the thing to make sure kind of worked in the extreme. So I wanted it to be very kind of high performance in the materials, but very high comfort and cozy in the function. And again, this is another one you have to add, it's ridiculous, but you add 20 pounds of lead to ship it. But it also, in terms of inventory and everything, the bases all stack up on each other like egg crates, and the tops all stack on each other, so it's really compact. I mean, that kind of thinking in the world of consumer goods really goes a long way and doesn't really get thought too much with architecture. So that's an example of 2 materials where each form was its own material. For the AIA convention with Bill Chrysler, we're doing another carbon pavilion for the AIA convention in Chicago this year. But Bill is really pushing composites in architecture. And he wanted to do something with with an EPS mold, where we use 2 different materials and use the same mold. So here, because the enemy of all this stuff is you have to build a tool to build the shell. So here the tool and these stainless steel rings let Bill cast a kind of resin and fiber infused cement with a FRP translucent skin. And this material, you know, if you lit a match under it, like just bursts into flames. So we then spent a couple of years getting this translucency to work in a code-compliant structural material rather than a decorative surface, which I'll show you a little bit later. At the same time, I was asked to do this jewelry for Swarovski, where we did the same thing in the sense that it's one surface with 3 different materials occupying that same surface. So again, that's the principle of a composite, is that with one form and multiple materials, you achieve an effect that you would otherwise have to do, like with a ring and a setting and a jewel. And so it's just to show that it works across a lot of different scales. Also with Swarovski, there was like a kind of a big insight about structure in these composite shells, which is that the structure is really working at the scale of fiber. So the fibers end up getting placed along the load paths rather than singled out and identified as a member. And I worked with North Sails, which has a digital fiber placement tool on a big deformable bed that they use for making semi-rigid sails for like America's Cup boat racing at the time. And they're able to locate 7 fibers along any path that you would specify. So the naval architect or the sail designer makes a shape of the sail, which they call the flying shape, and that's the optimal shape. They take that into finite element analysis and figure out where all the stresses and loads are, and then they place the structure wherever those loads are. So instead of using the structure first to define the volume or the surface, which is what I was used to, drawing blue lines as center line of structure and determining structure and then working the volume from that, here the form and the structure are totally disparate, and they're integrated at a fiber scale. So, you know, here, the pattern of all those fibers, you know, I had seen in the Prada ads for the America's Cup in '99. I mean, so did Renzo Piano. So did a lot of architects that started using this material because it has the look of kind of microscopic structure. And it's really where I learned the principle of fiber, you know, rigid fiber construction. So the latest thing I did with that, which I know in the 90s, I worked with Happold. They were kind of the engineers that I always worked with. They engineered the church and the Cincinnati Country Day School, and Craig Schwitters was kind of the young Turk at Happold then, and they had a structural analysis tool called a rolling ball tool. And Happold was, because they'd worked with Frey Auto, was the only engineering firm that could really calculate fabric structures. But every time they did that, they gave me these very sad shapes. I mean, I don't know how else to refer to them, as they just looked sad. They're just hanging. And I kept saying, well, can't we change the shape a little bit? They said, no, the structure picks its own shape. And I said, well, does the shape always have to be so sad? And they said, yeah, it's a hanging shape. They said, well, you could turn it upside down and it's not hanging anymore. But I didn't want to be finding form. I wanted to be designing it or defining it. And with this material, we're doing these lightweight shells now, which behave as tensile shells when you load them. We're just doing it right now at the scale of furniture, but we're scaling it up to get to be quite a bit bigger than that. But this was done for the Art Institute of Chicago. And what it is it's a chair which is made out of tapes, very, very thin tapes, actually the lightest, strongest material that exists right now. And the tapes are so fine, they just fall apart in your fingers if you try to hold them. And the tapes are laid with a laminate schedule, so there might be 10 or 12 layers of tapes in the corner. There might be, we can go down to 3 tapes before the thing starts to shred. And we mold it, so that's what a thick layer of those tapes looks like, but you can see through it. And we put it on a mold and vacuum bag it and cook it in an oven so that the form takes the form of the mold under its own weight. So it's in compression. It's still soft, so you can fold it and roll it up and put it in a FedEx pack and send somebody a hanging chair. But when you take it out and snap it into shape, it turns into a compression shell. And so it's a shell that's under compression, so you can give it form. But then when you sit in it, you overcome the compression loading, and it turns into a tensile fabric. So then it starts to behave like a lightweight fabric in tension. And we had 1,000 pounds of architects in this one 2 years ago at New Year's Eve, and the chair weighs 6 ounces. So it's incredibly light. I mean, in the wind, I've had one outside for a couple years to just see how it lasts, and the thing's like blowing around all over the place like a leaf. And you can also see all the details and things. It's all glue. Like, I've really come to hate metal and mechanical connections. So the whole thing is all just fiber and glue. It's about 75% fiber and 25% glue. And that's all it is. And you can see that's 2.5 mil spectra. And there's a naval architect in my office, Fred Karubla, who calculated that we could do it with 1 mil, which is like fishing line. But we all realized nobody'd sit in it if it was just fishing line. But anyway, super, super light and strong, but also not a kind of sad hanging shape. Okay, so now kind of the second 15 minutes, I want to just talk about recession planning, mostly for the students, because even though we're coming out of a recession, sometime in your life you're going to hit one. And I'm not like a big fan of the grasshopper and the ant thing, but when times were good, I always worked to get paid. I never did competitions for free. I've never done free work. I don't do proposals for free. It means I don't get to do a lot of the things that some other colleagues of mine do, but I always get paid. That's like basic principle number 1 is get paid and squirrel some money away. And so I squirreled some money away. I think maybe certain people in my family structure might think not quite enough for what I've been investing, but anyway, I had the resources to get through the recession and actually invest in myself and invest in research and invest in what I want to be doing in the future. And I don't really believe that you look forward and predict what's going to happen. I think you invest in ideas and communicate those ideas and make the world for yourself you want to live in. And so these last 2 or 3 years, I've really been focused on building up, I would say, three interests of mine. The first, Brian already mentioned, which is the embryological house I'd done 15 years ago, went to the CCA a while ago. And I very innocently said, well, along with the 1,000 models or whatever, would you like the digital files? And they said, well, sure, we want everything. And I said, okay, well, so what do you want me to do? You want me to send you a hard disk? Do you want me to send you CDs? I said, the Silicon graphics machine is the only thing that'll open these files. Do you want the machine? And it raised a whole bunch of questions for the CCA, which they took very seriously. They actually undertook a 2-year study with the Langlois Foundation and DOCAM and Library of Congress. And became very invested in trying to think of the relation between models and sketches and drawings and instruments of construction and correspondence and all that stuff that they already were looking at, and its relation to digital tools. And Mirko Zardini and Phyllis asked, would I help them think through how to collect digital materials and help them build a digital archive. So for the last 3 years, I've been working really closely with the CCA to kind of help, more or less to just bring up problems. I mean, that's my job, is to make problems, and then they try to figure out how to address them, and they're really the only institution I know of in the world of architecture, but actually, you know, they're really trying to think through what the digital means, and it's really exciting to see this institution tackling these issues that are going to have a big impact on how scholarship and research is done. So that's one thing I've been doing. Brian also mentioned at UCLA, we've kind of rethought our Masters of Architecture 2 program, and we've rethought it in a way that the 1 year that our MArch2 students spend with us, so that's an image of the first Archaeology of the Digital show. We're doing 3, and then I'm out, just because it's really a lot of work. But the first one was 4 projects, and we're progressively ramping up until we'll have 25 projects in total that come into the archive, and each one of those projects will be included in one of 3 exhibitions. At UCLA, I'd done the master plan for a developer that bought some historic buildings where Hughes built the Spruce Goose, which are all landmarked, and ended up through that relationship being able to get one of those airplane hangars for our MArch2 students at UCLA. And with Hitoshi Abe, who's the chair, he had started to rethink the teaching model with what's called a super studio, where now all of the instructors have students for a full calendar year study with them. And the instructors are paired with some institutional or industry partner. So 3 years ago, I did a year-long studio with Disney Imagineering around the time they were thinking about Shanghai. Last year, I did one with Cirque du Soleil, where we thought about how to take the robotics from their theaters and have them have some presence in the city. And this year, I'm working with Boeing to rethink the 3-dimensional factory environment and also to think about how large-scale autonomous elements that fly could be integrated into the built environment, because these are all, we'll typically work up maybe 12 or 15 topics and then vet them down to 1 or 2 that we focus on for the year. But it's a very new model of education where for a year, students work intensively with one faculty member and a team, faculty team, but do it with industries who are in the business of innovating. I mean, if Boeing isn't 10 years ahead of Airbus, they're out of business. If Disney isn't 5 or 10 years ahead of Universal, they're out of business. So these are all companies that kind of wake up in the middle of the night screaming that they don't have ideas for 20 years from now. So it's not like somebody just says, here's your program, you know, please do me a building. There are people that are saying, how can architecture help me think about what's going to be happening in our business? So it's a very new approach, and it's taken a lot of focus and energy, but I really feel like I did 20 years ago with all the digital technology. It's a very new set of interests. And then the thing that's just wrapping up in the next month is I'd been working in the Middle East for the TDIC in Abu Dhabi, and all of those projects during the recession tanked. And they said, well, look, you know what we need is we need a couple of boats. Did you ever think about designing a boat? And I said, sure, you know, I'd love to design a boat. So, and I had not really been sailing. I sailed as a kid, but I'd gotten out of it. But all the composite stuff I was doing had me connected with America's Cup levels, structural engineers and manufacturers. And I started, you know, going for rides on America's Cup boats and hanging out on boats and getting more interested in sailing. And Frank Gary's a lifelong sailor and good friend. I started sailing with Frank, and then the contractor for a house I'll show you was a sailor. I started racing on his boat, and anyway, it was all kind of preordained that I was going to end up doing a boat that flies. So, so what had happened is I'd realized in this world of high-performance boat racing, like the America's Cup, but a number of things, there was more innovation per dollar going on than anywhere else, more than aerospace, more than anything. They were really transforming their world faster than anything I'd ever seen, and they were really doing it through materials. And I got really interested in all those materials and also got interested in the tools they were using. Because you can't buy a boat that flies commercially, and you can in a month, but I had to design one. So I started working with a naval architect and going back to my roots, which was using computational fluid dynamics, like particle flow and things like that, which in the 90s I was using as kind of some pseudoscientific bad art project, but now was using in a very intuitive way. And it really just had to do with the power of computers now. I also started to think about how to design a projectile, like a thing that, you know, and this is something I really want to talk about with Brian, because Brian 20 years ago was talking about projectile thinking, how forms had motion built into them and cued motion and really were projectiles. So, you know, designing a thing that moves through space at speed. And also, you know, this idea of load path fiber construction. So we started, Fred and I started, and by the way, there's no science to any of this. We started with a platform. We started with certain volumes to that platform. It's very driven by the fact that Fred and I will sail this to Hawaii, so there needs to be room for 2 of us in here. So the interior volume was driving a lot of it. But how it moves through the water and how these, you call them chines, but how the surfaces develop volume along their length and how that volume interacts with the water. And, you know, this boat wants to flip back over front, doesn't flip over sideways. So putting reserve buoyancy, like more volume up here, so when you start to nosedive, the buoyancy keeps you from going all the way over. There were all kinds of concerns that we would check in a computational fluid environment. So in the 90s, we were just blowing particles around and trying to capture them as form. Here, we're blowing particles at a surface and studying the behavior of that surface. And this, to do this, this is 60-some computers running for a week to give you one result. So we had a farm of computers doing all this analysis that would give us that. In the 90s, you just couldn't do it. These are the kind of results you get. This is one of the reason we got all this computer power is because no serious person would trust the data. But it's the first time anybody's ever looked at coupled aero and hydro behavior. So with the CFD environment, you get up to 7 variables. And here, we're putting 4 of them in the air and 3 of them in the water. So the boat is in a digital environment sailing itself. So the reason it does stuff like this is because nobody's driving. But it tells you a lot about the behavior and the buoyancy of the boat. And it really does fly. It gets up and flies on these little carbon appendages. So the question is just how to get it flying as quickly as possible. We also get information back where what's called laminar flow is separating from surfaces, which is a bad thing because you get parasitic drag and turbulence. So we would get back, and this is something you'd get overnight. For 3 or 4 months, I was working every surface to get rid of all the aerodynamic drag and hydrodynamic drag off surfaces. And that kind of, you know, it affected everything all the way down to like very small details on the boat. So, you know, high performance was definitely a concern, but also, I don't know if you've ever looked at a boat, but they're really not very well designed in terms of being objects of beauty or styling. So I kind of realized this was very low-hanging fruit if you want to have an impact in a design field. Like, you can go in and design a really good-looking sailboat, and there's not a whole lot of competition out there. The only competition there is are some Italian architects, actually, that do those wallies and things. So what was kind of more of something I'd never thought of is in designing the interiors, which were kind of not only 100% my scope for design, but also 100% my scope for manufacture. I started thinking about the interior of the boat based on a story I heard about Philippe Starck. I was working for a company, Beneteau, for a while, and Starck did some boats for them in the 80s, and they told me that when Starck first met with them, he said, you know, if I'm going to work for you, I don't know anything about sailing, so you're going to have to give me a boat. And they said, okay, here we go. And he said, no, I just need to spend a summer in it. So they took a boat, and they took it to his house in southern France, and they parked it in his garden, and they left it. And he called them a couple weeks later, and he said, aren't these things supposed to be at an angle? And they said, well, yeah, actually they are, but when we store them straight up and down. He said, well, how am I going to figure out how to design it if it's straight up and down? So they came back, and they made a special cradle for it, so it was at a 20-degree angle. And he spent the summer kind of sleeping in it every once in a while and cooking in it and hanging out in it. And it's a testament to his intelligence that he did it at an angle. And so when they told me that story, I started with my digital files all the time putting the interior at an angle and trying to imagine what it's like to sit on it when it was at, this one's at about 12 degrees. So the interior was all designed to roll around. The interior elements, we spent 6 months building before we started building the boat, and we did these in my office. We cut all the molds out of cheap EPS foam, coated them and waxed them, and became experts in lamination. I mean, I think I can now safely say my office is one of the premier closed mold carbon fiber laminating shops in Southern California, which is saying something because there used to be aerospace in Southern California. But so you would laminate a layer of skin, and then because these forms are very tight and complicated, we'd vacuum bag them down, add a layer of core. So it's just like an I-beam. You separate the skins to make things stiff, laminate again, bag again, way apart. And then what was amazing, because this boat is like a kind of Formula One minivan in the sense that it has an interior, but most race boats don't have interiors because of weight. You don't even paint most race boat interiors because of the weight of the paint. So we weighed everything, and before paint, all the furniture for a studio apartment weighed 55 pounds, but after paint, it was 80. Pretty incredible how much paint weighs, but it also tells you how light these carbon fiber parts are, that they're just 2/3 the weight of the paint, or twice as much as the weight of the paint. So we built all these interiors, and really that process and working with an aerospace engineer to do the laminate schedule for all of them got us prepared to do the working drawings and the design of the boat. For some of the molds, we CNC cut the stations and strong backs, and then the boat builder, Westerly Marine, put door skins on them to achieve these mold shapes. And then I traded in every favor I could with Bill Chrysler to make it affordable, but we cut these giant molds for the 3 hulls on his mill up in Sonoma County. And then, you know, I just said, we'll throw them on a truck. And they're like, well, no, it's 4 trucks. So we brought 4 truckloads of molds down. And those were, you know, pretty rapidly prepared for molding, but then the same process at a much bigger scale. You know, waxing them and sealing them, laminating a layer of wet carbon, then vacuum bagging a layer of core, then putting another final layer of wet carbon on it, And this is all two general fabrics, a plus minus 45 and a 090. So every 22.5 degrees, you get a fiber. So it's kind of general omnidirectional fiber. But then everywhere there are loads, you lay tapes or you lay computer pre-cut kits of reinforcement. And then the whole thing is glued together. There are 3 pieces of metal on this entire boat that are like the size of a watch. So no metal at all. Everything is all carbon or aramid or Dyneema. So it gets all glued and bonded together. And then actually before the first layer of carbon goes in, they prime it. So it comes out kind of pre-painted and primed. Those are the 2. This is one hull right side up, and that's the other one upside down. And then these arms. This arm weighs, one is about 200 pounds, the other's a little less than 300. And if you support the end and the middle, you can cantilever 13 tons off the end of it. That's the load that it has to carry. So incredibly, it's 9 times the strength of steel for its weight. And it's all tapered, so unlike an I-beam, which gets just extruded for its maximum load at the center, this has 120 layers of carbon in the middle and 6 layers at the ends. So everything is, economized to save on material and to eliminate waste, just because of weight. That's the cockpit. Then that's the main hull. And you can see this line is there to give extra volume for when you nosedive. And you'll see the end of it is like a knife. So it goes through the waves until it lifts off. And then this is also like a knife, so that if you do pitch pull and go nose down, you can pop back up real easily like a knife. But then in this area, you'll see it's really incredibly fat. So if you're going down, that'll keep you from going all the way over. And then these lines are here, that's the edge of the seats and the couches and berths. So this is here just to give interior volume. And then these things are where the windows are, is to give some bigger space down in the living space without having to generate a whole bunch of surface area. So, it's a combination of the interior and the performance and also just holding these lines for a long time to make it look pretty. You can see how thin it gets at the one end. But anyway, for me, it's a real combination of ridiculous high performance and high style design. I mean, that's where I'm trying to go with this. The interiors. And then even some of the little details we also, manufactured, like the hatches and the tillers. But again, all 100% carbon composite. So it's a pretty serious structure, all built out of cloth, just rolls of cloth. So that moving thing with the interior that rolls around was just in the back of my mind. And 2 things came along. One is I was asked by Stan Honey and the America's Cup Committee with Bill Chrysler to design deployable autonomous buoys for the America's Cup race. And the idea was they would take these out on boats and throw them overboard, but they would be able to position themselves with thrusters, so whoever the race management was with an iPad could send one 200 yards away and it would hold its position without an anchor. But you can only push a thing with a foot of waterline at a little bit more than 1 mile an hour. There's a principle of length, waterline length to speed. And so they were looking at how heavy they would be for them to take all of them out and throw them overboard. And I said, well, since they're battery powered, if we just send the batteries to one end and flop them over, we could have a 20-foot long boat and they could just drive themselves out to the race course. So we came up with this kind of pivot idea of a buoy. So, and that got me starting to think about rooms which would pivot and move. For the London Olympics with Christian Moeller, We lost the competition to Anish Kapoor, where he did the big red tower. This was for the same site. Zaha and I were asked to design a pavilion, and I designed this pavilion with Christian that would follow crowds around and be like a little golden dome. And you can see underneath, it's 3 industrial robots on a rail that gives the thing its motion. So, you know, to do this shell, each one of those robots carries 350 kilos. So the shell had to weigh a little bit less than 2,000 pounds. So the idea was to use kind of carbon fiber manufacturing to make as light a dome as possible so it could move actively. And I was asked to design a domestic space that was 60 square meters. And I had the idea that in a 60 square meter footprint, you could put triple the amount of surface area if you could roll your house. So I started off with this idea that you could have, you know, a bed and a nightstand and a table that would all be gimbaled like you would gimbal something on a boat, so that as, say, your dining room table goes on your ceiling, all the stuff on your table stays level, and the bottom of your table becomes a chandelier. And same thing for all over the house, that all of the elements that needed to stay fixed would be gimbaled, and they would disappear into the walls of the house and become lighting or, you know, some kind of feature. So here you'll see, you know, kind of sleeping, cooking, living. And at the other end, that's the bathroom. You know, you can see that's always rolling around in that pocket. And then in plan, those 3 spaces, so bed and even a closet that kind of drives around, you'll see. And, you know, we built a model, had a fairly modest budget to do this for the Cordric Construction Fair. And decided we could build a 1/5 scale model of this room without all the interiors in it, and focused on the robotics and the structure that would allow it to happen. So you can see there's a ring that makes a kind of a column or vault, depending on what orientation it's in. And that's how this thing can pivot through 180 degrees of motion. And then it sits on a turret, so as you're flipping it around, you could point views. Again, I'm sorry that this was a house, because I don't think this has much traction as a house. No, I mean, that's not where you would start with something like this. Anyway, this is the kind of robotics with, you know, simple stepper motors and Arduino boards, and we now have this is the one this thing has been, it spent 3 months at Facebook, 2 months at Google, and 2 months at Red Bull. So these creative space people love the idea of a room that can roll around. And in Facebook's case, a room that can drive around. So, I mean, as a house, a lot of architects think you innovate with a house. That's not right, but this approach to an interior volume, which is robotic, is in development in office interiors presently. Kind of where that composite stuff has gone, in a very funny way, I was asked to do temporary facade elements for Site Santa Fe, which have now become permanent. But it was for this Art in the Age of Truthiness. And I came out, and the first thing I noticed was just how every corner of every building in Santa Fe is eased. Like, there are no hard angles. Everything is filleted and radiused. So I thought, well, why not do kind of giant Adobe composite elements? So for all of the major entryways, windows, and passageways in the museum, we did these lightweight composite scoops with the idea that the donors to the museum would take them, but they're all still there. And then with the Bloom house, which kind of was tracking this stuff simultaneously, we did a lot with plastics and composites in terms of making like a cozy interior. It's a house that's on a walk street, and it's more or less a row house. It's got a 4-foot side yard setback, so we just filled the whole volume. But the interior is a one-room living space, but it's not like a loft, it's very cozy. So by changes in floor elevation, we kind of break the space up, but also by folding the walls around and making these pockets, we get intimate spaces within an otherwise single volume. And to give it scale, I wanted to pull the ceiling down so this space wasn't too kind of disproportionate. But I wanted, like that lantern I showed you, to have this be a glowing, translucent composite. So we work with Bill Chrysler on that. And then to synthesize everything, you know, all the windows end up pinching into one reglet. So it's like one ribbon window in a way. So these are photographs kind of going from the walk street back into the house. So you see this, you know, fire and smoke rated translucent composite lantern. The off-the-shelf things like sinks and hearths and everything are kind of absorbed into the walls. But for me, this is really like a kind of rolling around ergonomic space, just the pieces don't move, but the surfaces all stay very continuous. Back at this dining level, it steps up and you get this kind of curved wall that folds around, and then a home office that also folds around and makes a little pocket room. And then because Corian has just lost their patent, or DuPont has lost their patent on Corian, they worked with us to develop a thermoforming method to get Corian into these fairly deep pulls. So all the wet spaces, like this breakfast nook and this kitchen island, like I said, I hate metal, so all the cabinet pulls and everything are all integrated into the Corian surface. And then in the bathrooms, stock sinks and boxes for cabinets are all integrated into this folded, voluptuous Corian surface. So that's it.